Now, last time we left off by creating the boundary surface that went from our steering wheel face to the front face of our airbag. I want to show you a few things that we did and ways to improve the quality of the surfaces you create. By going to my Evaluate tab, I'm going to turn on my curvature display. Now what this shows you is a color display of the radius of curvature of your part. Now you'll notice in sections like the top edge of our steering wheel base, it's a single color blue. This is because an arc, such as these areas here, are going to be a constant radius of curvature. Areas where we use splines, such as areas here, are going to have a variable radius of curvature, and areas that are straight, such as here, have no curvature. So it's important to note the differences between these three sections and how they're going to affect your surfaces. You'll notice this section here, there's a black segment that's basically zero radius of curvature, and it transitions all the way up to red, which is a high radius of curvature. The important thing I want to note is the difference between this upper surface, blue, that's a fairly consistent radius of curvature, to the corner where we applied the tangent relation between our surface. When you apply a tangent relation between surfaces, this is only affecting the direction of that surface at the intersection between the driving surfaces. What you want to do is use the equal curvature relation. We'll go back to change the relation between that edge to curvature to face, and you'll notice that we instantly get a change in the curvature combs. I especially want to note the difference here. What we're doing now is changing the curvature based on not only the direction of the curvature at this edge, but also the curvature amount of the edge leading into it. If we go ahead and OK this, we can instantly see the difference in the curvature display. Instead of having a bright red color in this corner as we transition into the blue, we actually get a blue transition that fades into the curvature in our corner. So this is a real good way to make sure that you have a nice smooth transition between your surfaces. Another thing to note when we're in our boundary surface is the display options. We have a mesh preview. We can change the density of our mesh, which effectively increases the number of curvature combs in both directions that we see. We can also change the scale of those and the density of those. If you need to focus on curvature in a certain area, especially on such a large surface like this, a lot of times it makes sense to kick the mesh density up. If you started off at 3, you might lose a lot of detail in certain areas, such as this where we have a large broad section, but we are going from a straight line up to a curve, and we want to understand what the curvature is doing in this area. So if we kick this up, take a look at the preview, we can see we actually have a fairly nice transition between here. Also, we can turn off direction 1 or direction 2 at any time, because once you kick the mesh density up, we get a lot of clutter on the screen. It makes it hard to understand what's actually going on. For instance, if I turn off direction 2, we can tell that we still have a changing curvature in this corner. We have a concave, convex, concave change in one small area. And depending on the intent, that may or may not be a bad thing, but for us, we want to make sure that the end goal is to closely replicate what we're seeing in our images. So for me, I'm going to go back to my Surfaces tab. I'm going to knit everything together. And I'm going to turn my Real View graphics on and take a look at how the reflections affect the surfaces. So you can see here as we rotate around, we want to make sure that the transition of light across our surfaces is nice and smooth. And this is extremely important, especially when you're dealing with designing plastic parts. In this case, we're dealing with an airbag, which has actually got a textured rubberized material. So the final quality of the surfaces isn't nearly as important as if it were a plastic part on the same steering wheel. So for the purposes of our part, I'm going to turn Real View graphics on, and we're going to accept the quality of this surface because it suits the design intent. To make sure that everything we've done with our helper surfaces and all the surfaces we've created has worked out properly, I'm going to go ahead and mirror this part across our right plane. I'm going to mirror bodies. We want to go ahead and knit this together. And I'm going to turn off my edges. Now the important thing to note here is that there's no seam between these two surfaces. The transition is nice and smooth. We also want to rotate this around to make sure that carried over with the last boundary surface we created. Because we didn't create any curves or any helper surfaces, It's important that we relied on the geometry of our original surface to carry that relation across. Everything looks nice and smooth, so I think we did a good job here. So I'm going to delete my knit, delete my mirror, turn my edge display back on, save our file, and that's a good place to end.